In Einstein's theory of general relativity, he states that space and time exist absolutely but are not independent. They are interwoven into a single fabric called spacetime. Basically, gravity is spacetime curvature. The curvature of spacetime is affected by mass. A massive object in space will create a sort of bend in the fabric of spacetime. The more massive the object, the greater the bend. Objects such as black holes can create curves in spacetime that are so big that instead of just making a bend in the fabric, it creates a mysterious hole. In this video, we will attempt to show how this curvature of spacetime affects mass in our universe.
Imagine that you are this happy little ball traveling through space. If there aren't any objects to interfere with your path, you will travel straight forever.
Again, imagine you're this happy little ball. You look to your right and see a massive object. Your life is about to change. As you move closer, you're attracted to the object.
At the space park, we are here to measure how even more massive objects affect this happy little ball. Notice how this happy little ball is affected by an even more massive object, creating an even greater curvature in space-time.
Here we have another example of an even more massive object that causes an even greater curvature in space-time. He can't even get out of this hole. Gravity is just dragging him in.
Imagine you had enough mass to create an even bigger curvature in spacetime. Big enough that it created a sort of infinite hole. We call this a black hole. We'll never see that ball again.
The curve that black holes make in spacetime creates a tidal force on any object being pulled into it. A tidal force is when gravity is pulling on one part of the object more than the rest. Kind of like this. Slips into the black hole, the part closer to the middle of the black hole is experiencing a much greater pull than the rest. Sometimes this force is so strong that it can rip apart the object being pulled into the black hole. This is called spaghettification.
Okay, not quite like that. But the idea is simple. This astronaut on the left is experiencing spaghettification. The tidal force coming from the black hole on the right is pulling on his feet a lot harder than his head. We hope that you now understand a little bit more about how gravity works and why an object that goes up must come down. What we know today about space-time and gravity and how it affects massive objects in the universe, we owe to Albert Einstein and his theory of general relativity. Thank you for watching and have a great Christmas break.